Please welcome Bratin Saha, CEO, NTT Data AIVista. Roli Agrawal, Chief of Staff for AI Strategy and Sales Transformation at NTT Data. And Moderator Mona Charif, Chief Marketing Officer of NTT Data.
All right. Hi, everyone. How's everybody doing this morning? Good, 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 good. So I'm Mona Charif, and I am the Chief Marketing Officer for NTT Data, Inc., and I'm thrilled to be here at Upgrade with all of you, and especially with Dr. Bratin Saha, who is the CEO of NTT Data AIVista, based right here in Silicon Valley, and my friend Roli Agrawal, who is based out of the UK and oversees all of NTT Data's AI strategy, our portfolio, our partnerships, and the services software product development, which she works on very closely with Bratin and his team. I don't know if Gomi-san and Chris Shaw are here with us, but I do want to thank them also for having us, and I think we're going to go ahead and get started.
Awesome.
Right? Okay. So the topic for us is, we've seen incredible advances in AI, but is AI alone enough to make enterprises truly intelligent? So that's what we're going to explore in this session today, and we're going to talk about what happens how intelligence emerges when multiple technologies come together. So Roli and Bratin, I'm going to start with a question for each of you, and it's a quick question, hoping for a quick answer for what intelligent enterprise means to each of you. So Roli, you want to go first?
Absolutely. So for me, an intelligent enterprise is where multiple technologies get integrated in real time, so the systems are able to continuously sense, simulate, decide, and act, and not just analyze. In a way, I think about it as humans, because of course, we have our 5 senses. We have our brain, the whole nervous system, and limbs, which are helping us sense, think, decide, act, and most importantly, learn too from all those things.
And I would say the way I look at it is, to me, an intelligent enterprise almost mimics what an intelligent society does. And if you think about what an intelligent society does, what have we been doing? Our essence of our intelligence is really learning from a context, getting better over time, and so on. And that goes right into what Roli said, which is, how do you ingest stuff from outside, which is all the sensory stuff you have, and then how do you process it and over time keep getting better at it?
Okay, so that's really a helpful kind of foundation. Roli, there's a lot of focus on AI as a driver of transformation. And you and I have talked about this alone. You said AI alone is not sufficient. Why do you believe that?
So AI is critical, of course. But to your point, AI alone is not enough. AI alone is like having a brilliant brilliant brain, but in a jar. Very smart, but there is only so much you can do with it. In real world, intelligence comes from closed loop systems. So what is happening there is, again, as I said before, you are sensing what is happening around you. You are analyzing those scenarios, making the decisions, and doing all that, and acting as well in real time. And this requires much more than an AI model. It requires all the sensing technologies that you have, your connectivity technologies, compute, and control systems, and all these have to work together within the requirements of things like latency, determinism, reliability, etc. I mean, we can see an example around us. We are in Valley. How many of you have taken Waymo?
Love
a lot
Waymo.
Of you, right? So we love Waymo. We love autonomous driving. AI has really enabled it, but AI alone, again, is not enough in that context, because you have the car, you have all those cameras and sensors around it, which are sending the data to the edge compute in the car and to the cloud, connected by low latency network, very low latency, because if a person comes in front of the car, it has to react and stop. And things like the thermal engineering in the car that you need to put, and even more importantly, things like innovation in regulatory framework that enable all that technology to get used properly by humans. And this isn't a new phenomena. Like if you look back in the history, every revolution we saw this. Industrial revolution was not just about engines. It was about engines, electricity, and much more importantly, all this transport infrastructure and logistics. If you look at the digital revolution, the real GDP growth did not come with the PCs. It really came when the PCs were married together with the internet. So that's what I mean. Like AI may be the brain, but without the technologies around it, without the systems around it, what I would like to call combinatorial innovation, it can create
rolls off the tongue, doesn't it?
Easily.
Yes.
No, but without that, it creates only insights. AI creates only insights. It doesn't create the intelligence.
Okay, so that's very helpful. Bratin, when you look at the work that you're doing with enterprises, don't they have all of these pieces? And if they do, then why aren't they working together?
You know, the enterprises don't have some of it, but they don't have much of it. And let me explain why. If you think about AI, take the essence of what AI is trying to do, right? The essence of what AI is trying to do is saying, how can I become a continuously learning system and mimic how human workers work and mimic how intelligence works and so on. And that really requires you to be able to do things that previous technologies never had to do. Like, think of a PC. The PC didn't have to go inside your home or didn't have to go inside your enterprise and have to ingest all the knowledge and get customized to your context. You know, you could buy the same PC off the shelf from Best Buy and use it in NTT and use it in Intel and use it everywhere else. But that's not how AI has to operate. If you think about what humans do, you go through school, college, university, then you go to NTT and you go to some other company. Within a year, you're two very different individuals. You know, the way you do risk management, the way you do customer engagement, everything is different, right? And so this whole point around how do I take something, mold it, and make it work really well within this context is something that's new. It's not had to happen before, because up until now, we never had a piece of technology that said, hey, I'm going to mimic how humans work, right? And so a lot of this infrastructure around how do I take the AI, how do I kind of adapt it to your domain, how do I ingest all of the data, all of that hasn't been built and needs to be built. And more than that, and this is where I think, you know, entity data really has its strengths, more than that, AI today is not a technology problem to a large extent. If you look at the chasm between what the technology can do and the benefit that a lot of enterprises are getting, that chasm is pretty wide, right? And that chasm is all about change management. You know, how do you change the human AI? How do you change the human AI workflow? How do you change the human machine interface, right?
So you see AI as a change management problem?
Is a big change management problem. In fact, if today you were to go in and say, what is the biggest bottleneck in deploying AI and getting all of the productivity benefits out of it?
Adoption.
It's adoption. And the adoption, the friction to that adoption goes through change management.
Okay,
right?
All right.
And it goes through a layer of infrastructure that is yet to be built.
Yeah. Did you want to build on that?
No, I will, yes. Some of our clients actually are telling us that for every dollar of technology, they are keeping $2 for change management. It's so critical and so important.
So critical. So speaking of friction, how many people are staying in this hotel? How many of you are staying? So I thought the biggest IQ test I was going to have all week was how to get the shower working properly. But this idea of combinatorial innovation that you talk about, Roli, you've used this term. What does it actually look like in practice, especially within NTT?
Yes. I think, so one of the combinatorial innovation I saw was also on the stairs. These stairs, to get up on the stage, the stairs were combined with the tape to tell us where to go when you're walking up the stage. So if you have not seen that, you can see that after this.
We'll try not to get confused on our way down because the arrows only point up.
So, but coming to combinatorial innovation, so that is about moving beyond the siloed breakthroughs and designing these systems where multiple technologies work together from the start. And in NTT's case, what it means is that we combine our AI capabilities with advanced connectivity technologies like P5G or ION, or our edge and cloud compute capabilities, our sensing IoT technologies, or technologies like digital twin. And we bring all this together to make an enterprise really intelligent. To give you an example, think of an industrial setting, right? There are a lot of vision models in work there. But it's not about that vision model only. It's about all the IoT devices that you have set across the factories, which are collecting the information, the data, et cetera, in real time, sending them through ultra low latency network to either the edge compute again or the cloud, where you have your vision model, the digital twin of the factory sitting together, analyzing that data, doing some scenario analysis, and then sending back the action in real time. And this is how you are controlling the operations of that factory in real time using AI, but there is a lot of things that have to work together to make it really work. And a unique advantage with NTT is that we work across this whole stack, from sensors to network to compute to AI services, everything. So, which means that we can co-design the system versus stitching it after the fact. Yeah. The other cool example actually I just saw here, which is the optical quantum computing. So you have the optical technology, which is getting combined with the quantum, which is solving one of the biggest problem of the quantum, which is it had to be in -20 degrees. But in optical quantum computing, it can be just on room temperature. So I found that super exciting. So
it's pretty fascinating. And if you haven't had a chance to get over to the expo, do spend some time there. A lot of the technologies that Roli is talking about are being demonstrated there, and it's very interesting. Bratin, I want to talk a little bit about how NTT Data, well, I don't want to talk about it, I want you to talk about how NTT Data AIVista translates some of the things that Roli's been talking about into things that clients can actually use.
Yeah, in fact, I'll tell you an example that we are working on yesterday in association with NTT Data about how you have to touch each part of it. And I'll say one other thing, as I was hearing Roli speak, something came to my mind. If you look at how human intelligence has evolved, and I've done a lot of study on how the human intelligence has evolved and how the human brain has evolved, just to see if there are learnings from there in how AI comes. The human brain actually evolved a lot in this combinatorial way. So the first instance of intelligence actually came in from, organisms tens of millions of years back, when they were trying to see how that organism could be better at getting its prey. And so it actually evolved from seeing how do I get sensors, and then how do I change my body shape to be able to capture the thing. So it was all about not just let me get this brain cell done well, but it was about how do I get the brain cell done well, the neurons done well, the muscles done well, so that my business objective at that time, which was how do I capture the prey, gets done better. The next jump came, the Cambrian explosion, when we got eyes. That was all the same. You got eyes, you got a new form of sensory input, you had wires, network to your brain, and you started processing it, right? So the history of intelligence has been the combinatorial thing that Roli and you have been talking about, right? Coming back to your question, how do we do that? So I'll give you a real example that we have been working on with the NTT Data team, NTT Data Inc. team. So we are working with a customer, and that customer says, look, we have this process that is all human-based, and we now need to move this process to AI-based. So, we're sitting down with them and saying, hey, how you can move this to the AI-based. So we said, okay, let's just start with using one of the best frontier models out there, right? Now, when you use that best frontier model out there, we got about, and you can do the testing, you get about an 83% accuracy, right? You can use that 83% accuracy, but the problem is if you're only 83% accurate, you're invoking the human so many times that you're not getting any benefit, okay? So we did the math and we said, okay, Now we need to get to 95-ish. If you need to get to 95-ish, that model doesn't work. Going back to what Roli said, now we have to go and together with NTT Data actually have to change the model. So we did go and change the model, and we went from 83 to 92, right? And then from 92, we went to 96. Great. Now we went back and talked to the NTT Data team, and then together we found, look, you need to hit a cost target of 27 cents per document. The current combination that we have gets you to about 40 to 50 cents. You don't have any margin left. So you go back and redesign this, and then we'll ultimately go through this, and I think what will happen at the end is we'll say, okay, we need to run this model in a different kind of a GPU, right? And then, and if you go to a different kind of GPU, we'll probably shave 30 to 40% of the cost, and then we'll be able to bring it back. Then we'll have to go in one other part. I'm pretty sure we'll have to go in one other part and say, look, this is not working as fast as it needs to work. We need to improve the latency because you have an SLA to the client. So in this particular case, NTT Data Inc. and that client, they have an SLA to the customers that says you need to get this done in that time. Right. When you have to get to that, I know where we'll end up is, look, we need to get a lot more of it processed in memory. And then that will touch, okay, what kind of networking do we have? So you can look at it, if the reason I gave that initial example was right from the time that intelligence started, not even human intelligence, mammalian, or even not even mammalian, that was organismic kind of intelligence. It has always been about the business objective, which in that case was how do I get my prey, and how do I optimize a bunch of things. The sensors, well, in that case, it was the skin. And it used to feel, so, these were organisms in water. So they would feel the pressure of the water. So, how do I get that? How do I get my muscles to work? How do I get that little single-celled brain to work? To the current situation where we are having to go up and down the stack to meet the ultimate business objective, which is not automation. It is business ROI.
Very very interesting, and you also will have a chance to ask both of them questions. So we're going to save a little bit of time at the end. If you have questions, do prepare them, and you'll be able to engage in this conversation as well. Roli, I want to switch gears just a little bit to talk about energy. So AI at scale, obviously critical, but it's also incredibly energy intensive. So in intelligent enterprises, how do we make sure that the intelligence is both sustainable? What innovations are needed to make sure that it's still sustainable?
Sure, and Bratin, we absolutely would want 95% plus accuracy, or maybe 98.
I can't promise that. Maybe I should.
Too late. Too late.
Yes.
She's already put in your SLAs.
But what I'm going to say is that I love 98% model accuracy. But that is not the biggest constraint when we think about scaling of AI. The biggest constraint is energy. And if we don't address that, AI can cost us the earth, literally. And to your earlier point, comparison to humans, in AI, we talk about this AGI, artificial general intelligence. But human brain uses only 15 to 20 watt of power. So it's a million times more energy efficient. So we have to solve this, if you will, the energy constraint for AI. And I think solving that requires innovation both on the supply side and on the demand side of energy. And what I mean by that is, so on demand side, it's things like having small specialized models, or new architectures like neuromorphic architecture is emerging as one of the very promising things. Or things like, as you were saying, pushing some of the intelligence to edge, so a lot of back and forth of data is avoided, which of course consumes a lot of energy. Or innovation in our data centers like liquid cooling, then you would need less energy to cool it. Or things like, as you would see probably when you walk around, the ion technology, which is 100x more energy efficient, and of course 100x less latency. So all this from a demand side perspective, I mean, these are some of the examples. But then on the supply side, we need to power and run our AI much more efficiently, our data centers much more efficiently, which means we can use renewable energy or nuclear energy, although some of you will say that, okay, nuclear energy, you'll have to figure out where to put the nuclear waste. Maybe Elon Musk can figure out how to put it on Mars, but that's another story.
He's working on it.
Or maybe the distributed power plants near data centers. So there are things that we have to do on the supply side as well. And again, coming back to NTT, one of the unique advantages that NTT has is that because we run the data centers as well as all the AI services and the network and compute, we see both sides of this equation, both the demand and the supply side, and we can innovate and optimize both these together, if you will. And I'm hopeful. I mean, if I was reading about this very early computers called ENIAC. Have heard of it? Yes. So it used to use 175 kilowatt of energy, one computer. And there was this running joke at that time that when you switch on ENIAC, the lights in Philadelphia get dimmed. But we solved for it. Like the computers today are so much more efficient. So I'm very hopeful our AI will become much more energy efficient as well.
Well, not just hopeful, we're actually working on it. So.
Yes.
I want to make sure our audience knows that immediately after lunch at 1 o'clock, we do have a panel on photonics and data centers. And I don't know if Tim McKenna is in the room. Tim, are you here? He's not there. He's preparing for his panel. So Tim is a physics and informatics. He runs that physics and informatics lab for NTT Research. And even though I know a lot more photonics jokes than he does, he's really brilliant. And so come back at 1 o'clock to see his panel. But Bratin, jokes aside, from an AI product perspective, how do you make AI more efficient? How are you meeting her new expectations that she's just piled on about energy efficiency while you're making it more powerful?
You know, one of the things I'll say is that intelligence has always been an energy problem.
An energy problem?
Yes. Do you know which part of the human body is the most energy intensive? You would imagine that, you know, you expend the most energy in lifting weights or in running, right? Which is the legs or the hands.
The brain. It's the brain.
The brain.
Yeah.
It's the brain. So the brain is only 2% of your body weight, but 20% of all your energy. 20% of all your energy is the brain. In fact, one of the biggest things that helped human intelligence is, guess what? It was the invention of the fire. And the reason that it came about is that after the fire was invented, we were able to take food and increase its energy intensity a lot. So you take meat, you put it in fire, it becomes really small, right? And because we had a particular size, our intestines can be only a particular size, which means unless you can feed very high energy intensive food into our intestines, we would not have had the energy. In fact, if fire was not invented, we would probably have to feed ourselves for 60 or 80 hours a day. Now, you don't have 60 or 80 hours a day. In other words, we would not have been so intelligent, right? So intelligence has been an energy problem from the start. You know, and so as Roli was saying, as you were saying, Mona, what can we do? Well, part of it is better models, you know, more domain-specific models. So if you have a particular work to be done, maybe the place where I need to do real reasoning, I go to a very advanced model. Where I'm not having to do very real reasoning, I go to a different model. Better hardware infrastructure, you know, you can look at hardware becoming 10x more efficient every year, and then based on what you're doing, it can get 10x more efficient. Efficient delivery networks, Roli mentioned ION. A lot of energy can go in data movement. If you can make that much more efficient, you get to a much better place. I think cooling, Roli mentioned that. You know, if you take data centers, like typical, you know, when I started in the cloud space like 10 years back, a typical data center would have a PUE of 1.2, 1.3. Now, state-of-the-art data centers have PUEs of maybe 1.04, 1.06, right? So it goes back to what NTT does really well, which is its combinatorial. Even the energy, you have to look at everything and then go in and optimize it. And so that is what, we are collaborating with NTT Data in the form of better algorithms, better data, better models. In many cases, we'll get to better hardware, and so on and so forth.
Helpful, thank you. So Roli, I want to come back to you. If we want to move from isolated innovation to intelligent systems, what needs to change in how we build and how we deploy technology?
So I think there are 3 things probably that need to change. I think we have to build differently, we have to measure differently, and we have to scale differently. So what do I mean by that? Build differently. There is a running joke again in tech industry that everything works well until it has to work together. So that's why we need to move from siloed innovation to actually co-designed systems where the AI, the network, the compute, to your point, all of them have to, they are built in a way that they are working together from the start, and from the scratch they are designed that way instead of, as I was saying earlier, stitching as an after fact. The second one, which is measure differently, again, there is another always debate in technology. When there is an application rendering very slow on your screen, apps team says that, oh no, it's a network problem, and network team says that, oh no, it's the app's problem. But in the end, as a consumer,
you don't care.
I don't care what problem it is. It is impacting my experience. So that's why we need to move from the optimizing I mean, in the end, you might have to measure everything, but we have to really move from the component metric like compute speed, model accuracy, network latency, et cetera, to the system outcomes. And you were saying that, right? If the client wants low latency output from the model later on, client doesn't care if you're optimizing your model or if you're getting your the hardware better or if you're getting your network better. In the end, they need the system outcomes because that's what drives the experience. And third, I would say that we need to move from the, how I call it, the brute force scaling to efficient scaling, where energy, resource allocation, all these things are built into design from the beginning, and they're optimized in real time for different needs. So like your models, you real time send the query to the right model so that it's optimized for the energy efficiency. And again, comparing it to the humans, as in the humans, we actually know how to do it. So when our bodies come under stress, we reallocate all the resources. Our focus sharpens, all the blood starts to flow in your limbs, your heart rate increases, and a lot of other critical functions like digestion, et cetera, it slows down. So we are dynamically allocating all our resources. And again, as we move to AGI, I think we have to think, and all this, of course, our brain is doing. So if we are getting to AGI, we also have to think about all this resource allocation in the real time. By the way, on resources in real time, we found Bratin 5 minutes before this panel. So that was the real-time integration.
Real-time integration for the panel. So Bratin, I have one more question for you, and then I think we have mic runners who can help you ask questions as well. What needs to change from a product and platform perspective to make all this happen?
Yeah, first, I agree with everything Roli mentioned. You have to move away from that siloed innovation. The other thing I'll add, or maybe a couple of things I'll add, one is building truly intelligent systems is a complex thing. Like, all this orchestration, everything that you're saying, it's a very complex thing, and to get it right is not easy. So you don't want to have to build it over and over again, right? You really want to build the primitives once, so that you can reuse it as much as you can. And then the second, and so which really needs more of a platform approach, right? The second thing is, as you build this in different environments, you want your experience to compound. You want the learnings to compound. So Your third deployment is hopefully easier than your first, and your 10th deployment has hopefully learned from the first 9, okay? So this notion around reusability and kind of having more of a platform approach and a scalable approach, that really becomes important. The other thing that I'll also say is that if you go back and look at how we want these to be used, in the case of AI, there's the thing around, is the technology reliable? That was there with cars and PCs and electricity and everything else. There's a second aspect, which is it safe? Is it governed, right? And I think that point around how do we ensure governance and how do we ensure that the AI is aligned to what the human needs becomes a really important point. Yeah. Now, we have actually solved these, if you think of it, if you go ahead maybe 5 years from now, I think enterprises will have teams of humans and AI. Okay. Just like today, purely paper-based workflow is archaic, and you have digital plus paper workflows, you have purely human, maybe archaic, right? Now, how have we solved that problem? Well, we have a platform to do governance in our companies. It's called HR. Every company has a single HR thing. You don't have multiple HRs, right? So this notion around how governance has to be built right out of the box, and then how do you govern it uniformly, that becomes a very important part as well. So in addition to what everything Roli said, what I would basically say is, look, this thing is not easy to build, which is why we are here, which is what gets us all excited, yes. Right? And so the way you make it reusable, scalable, and affordable is to not keep doing the same thing over and over again and not keep making the same mistakes over and over again. And in contrast to every other technology that humankind has done, you need to have governance and safety built in from the ground up, not as an afterthought.
Yeah, true.
I thought last night you were saying it's very easy to build and I can build it in 1 month instead of 3.
I changed my mind. I'm not deterministic.
That's what keeps them challenged.
Okay,
that's what keeps them excited.
That's a good one.
Questions from the audience?
No?
It's a quiet crowd today. Edo, take it away.
Yes.
I think we've got Mike. There she is. Thank you.
I'll break the ice. So when it comes to the energy aspect, you've sort of talked about 3 themes. There's the algorithmic efficiency, like sorting a list. There's the power consumption efficiency, the ENIAC example, and then there's the fundamental architectural, hardware architecture aspect, which is ION. Now, if you look at the past 70 years of computer science history and software engineering history, the first 2 have completely been transformed, but the third one fundamentally hasn't changed since before any of us were alive. And for half of my career, I've been hearing about how quantum is coming and optics is coming, but we're still with copper and silicon, and it hasn't fundamentally changed. So do you think that this is really going to change in the next few years?
So I can take that and then... I don't know if I would agree with your assertion that the third thing hasn't fundamentally changed. And the reason I would say that is if you look at CPUs versus GPUs, a CPU was a one Newman machine, right? Sequential one Newman machine. And the way you were getting performance out of it was that the hardware, like out of order buffers, reordering and all that, ROB and all that, the hardware was trying to parallelize, and it would spend a lot more energy in making it happen. And the GPUs basically said it's going to be explicit parallelism, and I'm not going to do that, right? That difference led to like a 10 to 100x difference in in energy efficiency. Going from, there's actually very interesting work that shows when you go from FP32 to FP16, 8, and now 4, you have gotten like 10x order of magnitude efficiency, right? So I understand where you're coming from, but I might adjust it a little bit. Now, are we going to see fundamentally different architectures and so on? ION may be one thing, photonics may be one thing. Now you said, well, I've been hearing about it for some time, so will it come? I think that may be one of them. I think if you look at the domain-specific processors, so if you compare the energy efficiency, and I don't want to take vendor names here, so let's say you take the energy efficiency of some special purpose inference processor and even compare it to the energy efficiency of a GPU, there's probably a 10x more, in fact, more difference in there. Now, if you look at some of the model innovations that are coming, may not, it's kind of very researchy, like SSM models and so on. And if you look at some of the neuromorphic processors or some other kind of stuff, if quantum comes in, which quantum may come in at some point, then I think you get another like 3 orders of magnitude thing. So part of what I'll basically say is innovation goes into that necessity is the mother of invention kind of thing. And if you look at compute prior to AI, yes, we had energy intensity, but it was like a linear kind of thing. And now with AI, it started getting step functions up. So I do think we'll see the AI only happened because of the transition from human machines to GPUs, which was a very different paradigm. Okay, so I do think we'll see changes coming up.
I think the only thing I would add is when we are living in the times, 5-year, 10-year period looks very long because we have been living through it. But if you go past in the history, any innovation, to Bratin's point earlier, you're building on top, on top, on top. The 747 did not come in 5 years or a decade or even 20 years. It was like 50 years before that. Even PC, actually, internet and computer, no one even knows when it started. Or AI, I think the first test, the Alan Turner test that was done, that was in 1940s, 50s. So we've been talking about AI since then, when Alan Turner said that it's AI, when you cannot tell the difference whether it is, if your thing is answered by a human or a machine. So if you zoom out, I think the period of 5-10 years look very small blip, because these innovations probably take longer, but quantum is for speed primarily. It's not going to solve the energy problem. Ion in the chip, not the network, but ion in the chip, photonics in the chip is quite a good hope, if you will.
One more question. Yes, Wendy in the front row.
Thank you. Hi, Bratin. So you made the comment that the goal would be to build the primitives once, and I think that makes great sense. But it's challenging with intelligent systems because AI technology is moving so quickly. So how do you build primitives that are flexible enough to bring in new technological advances as they emerge?
Great question. I think the key is making it configurable. Okay. And that doesn't mean that what we build now, especially given the pace of AI, would be relevant maybe 10 years from now. But if you take a shorter time window, I think you can build it in that way. So it was more of a joke, but there's this saying, you can solve any problem in computer science by adding a level of indirection. It's almost like that. And that is some of what we are doing is, adding a layer of indirection or adding a layer of abstraction. So I'll give you one specific example. Instead of, let's say when we want to generate guardrails, right? Instead of saying, here is the guardrails that I want to generate, we are building it in a way such that you say, input me the requirements and I'll build the guardrails for you. Okay, so you go one level higher in terms of saying, I'm not going to hardwire anything. I'm going to go one level higher and input the requirements and give you what you need, right? So I think it goes back to you really have to take the time to take a step back and spend a lot of time in architecting it for extensibility. And nothing is perfect, but I think you can get a lot of the way there.
Thank you. So I want to close by asking you both about misconceptions about AI. So in your view, what is one misconception about enterprise AI that you'd like maybe this audience to rethink?
So I'm not lowering the KPI on model accuracy, Bratin, But I think one of the biggest misconception is that the best model or the coolest agentic app makes an enterprise intelligent. That is like saying, okay, a smart brain will automatically make you the best athlete ever. I mean, without the muscle strength, the training, the coordination, all the feedback, learning, it doesn't translate into any performance. So yes, enterprise intelligence comes from this whole system or the combinatorial innovation working together rather than just increasing just the smartness of one part of it, if you will.
I agree with Roli. You know, I'll basically say that the model is necessary but not sufficient, right? And the other thing I will say is that it's not just plug and play, which is the part that, you know, it's not sufficient. You really need to take a step back and think through the entire change. I'll go back to the change management. You know, this is not just a technology problem, it's a change management problem, it's an enterprise organizational problem. And don't think you're building an engine, you're building a car. And so then work back from what your business goal is. What's the kind of car you need for a business goal? Like, you know, if you're running a Formula One is one kind of a car.
Do I need a race car?
That's a different one. So you really have to work back from that and build the car, not just focus on the engine.
That's great, thank you. I want to thank you all for your engagement, for your attention. Chris, thank you again for inviting us. Thank you, and thank Gomi-san for inviting us. I'm gonna end on a joke, as I like to do. And you are not prepared for this, so we'll just see where your sense of humor is today. What did the enterprise AI learn to say after being trained on 20 years of corporate content?
What?
BS?
This could go anywhere, couldn't it? Bratin?
Basically said,
This is so unplanned.
Can you use AI to shorten the amount of, to make my work go so fast that I can retire from the day I start?
Okay, this is a
working.
joke. This is a joke, guys. What did the enterprise AI learn to say after being trained on 20 years of corporate content? It learned to say, let's take this offline. And with that, let's take this offline and enjoy lunch. And we'll see you back at 1 o'clock. Thank you both.
Thank you.